Good morning students. Today we are going to discuss about the Rankine cycle, which is a steam power cycle. So generally we are having three different types of cycles. The first one is steam power cycle. So in which the water is the working fluid which is going through many components and it will comprises many processes. So the second one is air standard cycles. In this Otto, diesel, dual and Breton, which is having the air as the working fluid. Air is the ideal fluid in these cycles. The last one is power absorbing cycle. Vapor compression cycle is one of the category. For power production in India, we depends on oil, gas, fossil fuel, nuclear energy and some of the renewable energy sources. But prominent and reliable energy source for our power production is coal only. So India is the third largest consumer of electrical power for our different applications. So China is the first largest consumer, and India we are having the largest thermal power plant which is located in Vindhyachal in Madhya Pradesh, which is having a capacity of 4760 megawatt, which is operated by NTPC. So the world largest power plant working on coal is located in Taiwan, which is having the capacity of 5500 megawatt, and coal is also the working substance. And Rankine cycle is the mostly used power cycle in steam power plants. So it comprises of four main processes. So we know that Carnot cycle is the best power cycle which is having the highest efficiency than all other cycles. But we cannot use Carnot cycle for our steam engines. So the main drawbacks in Carnot cycle is dealt here. So this is the TS diagram. We are having four different components and four different processes. So in the Carnot cycle we are having two isothermal processes and two adiabatic processes. So 1 to 2 is the compression process, 2 to 3 heat addition process, and 3 to 4 is the expansion process, and 4 to 1 is the heat rejection process. So the first drawback is partial condensation in the compressor. So at the end of the turbine we are having a two-phase mixture, liquid plus vapor. So we are having a condenser here. So in the condenser we are having limited condensation. So this is partial condensation. So the condenser will not condense all the liquids 100%. So at point number 1 we are having a two-phase mixture, liquid plus vapor. So the compressor has to deal with the two-phase mixture. So generally for a compressor it deals only the gas. In a pump it deals only the liquid. So for a two-phase mixture the compressor will not handle and it will not condense 100% to saturated liquid which is entering into the boiler. So that is the first drawback in the Carnot cycle. The second one is if we design a compressor to handle this two-phase mixture, we have to supply more amount of work for the compression process. So the higher compression work is the main drawback in the second one. The third one is the quality of steam that is entering into the turbine, that is inlet into the turbine, is very very poor. So the turbine blade will be eroded here. So this Carnot cycle which is having the highest efficiency cannot be used for steam power cycle. So this is the Rankine cycle. So the TS diagram for the Rankine cycle is shown here. So we are having four main components: boiler, turbine, condenser and pump. So 1 to 2 is the isentropic compression process, and 2 to 3 that is at point number 2 we are having the saturated liquid which is entering into the boiler. So in the boiler the constant pressure heat addition process is taking place. Then the saturated steam will enter the turbine, and from 3 to 4 the turbine will be expanded in single stage or two stage or three stage. So this is the ideal cycle. So we are having only one one single stage turbine. So 3 to 4 is the isentropic expansion process. So in the point number 4, that is the turbine exit, we are having two-phase liquid, that is a liquid plus vapor. So this condenser has to condense the two-phase mixture. So at the exit of the condenser, we are having a saturated liquid, because here from 4 to 1 we are having 100% condensation, that is full condensation instead of partial condensation that was taking place in the Carnot cycle. So our pump is replaced, so the compressor is replaced by a pump. So the pump can handle a single phase 100% saturated liquid. So 4 to 1 is the constant pressure heat rejection process. So all these processes are given in the schematic diagram. So this is the most efficient steam power cycle. Thank you.